Why no one go to waiting room?
Agama.
Why no one goes to waiting room? Nana, why no one go to waiting room? Huh?
Looks like someone is not mute. All right. So good evening, everyone. We are just going to wait for 2 more minutes, and then we are going to start sharp at 8:35 p.m. So let's give 2 more minutes for all the folks who would like to join in and they are yet not in the call. And can someone confirm if you are able to hear me properly and you can see my screen?
Yeah, sir.
Awesome.
Yes.
Thank you so much. All right. So let's get started. In the meanwhile, if someone joins in, anyways, this session is going to be recorded, so they can actually always go back and see what they missed. Let me just start with the introduction because we are meeting for the first time. So this is Imran. I am engineering manager in Microsoft. Been with Microsoft for last 13 years. Majorly working in the Azure division, bunch of services, and I have been teaching in Upgrad for last 6 months. And this particular session I have been actually taking for a couple of times now. So what I want to do is not really go into the lot of theory part because you would have actually already gone through a bunch of already gone through a bunch of theory part in your modules. Uh, what I want to hear from you, most of you, is what are you looking for from this session so that I can tune the session accordingly. So how much comfortable are you with the variables, data types, conditionals, loops, and functions? How comfortable are you with the coding now? So just share whatever you want to share. I'll keep reading in the chat, and once I get the sense of what exactly you guys are up to, we are going to tune our session accordingly. All right. So a couple of you have uh, written the response, and this is good. Always need more help, comfortable with programming. I'm familiar with this topic, but not very good at it. Okay, so the summary which I can actually see from your responses is you are pretty much comfortable with the topics. Obviously, some of you said, okay, even though we are comfortable, it's not bad to actually hear more about these things again. But a lot of you are actually also looking forward to something more in these areas. Like, for example, how do we program? What can you brief me more about functions and some people have actually questions around static and final concepts and so on. So what we'll do is looks like the need from everyone is different. So I'm actually going to let's see if we have a Q&A session as well. Just a moment, let me just check if there is a Q&A session. Looks like we don't have a Q&A session, so you can actually use we feel today for today's session as I went through this topic theoretically, however, not good on writing code. Okay, so a lot of you have given me response. This is good. Thank you so much because this is the first thing which I want all of you to do. Just be more and more communicating to me. So anytime you actually think, okay, we are actually going too basic, stop me. If you're going too advanced, stop me. We just want to make sure we are somewhere in between. So uh, let's do one thing. Let's get started with some of the very theoretical part very quickly because I don't have a lot of slides. This is a slide I prepared for my first session. When I was doing this session, I've been using the same slides. I will jump into IDE and we'll code and we'll do a lot of coding, and that is how we'll actually proceed. And then what I would want you guys to do is post your questions in the chat window. So once in a while, I'm actually just going to look at the chat window, answer your questions. All right. So let's get started. Obviously, what you have learned in your module so far, I already have your module open as well at my side. So you have learned about variables and data types, conditionals, loops, and functions. And then this is what exactly I also have in my PPT also. So we are pretty much in line. We know what is variable by now. I think most of you know variables, and so we don't really have to spend a lot of time on variables. The only thing which we should remember is variables eat up your memory space. So the moment you create variable and initialize them, they are going to be holding a memory space. So when you start coding decently and when you really are into coding and know about data structures and algorithms, remember, you create the variables only if you need. You don't end up creating a lot of variables. Reuse the variables if possible. So for example, use different data structures. You're going to see all the different kind of data structures which you can use. But remember one thing, especially from a variable perspective, they are space in computer's memory and they have a name associated with. Okay, so this is important from a variable perspective. And obviously, there is a very easy way of doing this variable. Let me stop sharing and let me see if I can share my screen. That will be easy. We can actually switch back between PPT and let me just close this one and this one, this one, this one. I'm just trying to share my screen. Before that, I need to close bunch of stuff. All right. So let me just share my screen. Okay, so let me know once you're able to see my screen again. So this time I have shared my screen completely. So I am actually going to switch back and forth between IDE and this. So we are also going to keep coding. So in the data types, control flow, let me just create a new example for you all. New Java class, and let's say we call it uh, fundamentals demo. So we are actually just going to use this class and write everything. Okay, and then we'll keep writing. So from a variable declaration perspective, you know exactly what it is. So if I say string instructor name is equals to Imran, what am I trying to do here? I am trying to create a variable of the name instructor name, which is of type string, and I am also initializing a value. And then this is in fundamentals demo class. I can write here different access modifiers. I can actually say, yeah, this is good. So let me just increase the font size as well. Let me know if this is good, or we can actually even make it a bit more. Let's make it 70. Okay, so this might be better. Okay, so what we are trying to do here, we have created a variable of the type instructor name, and we said the type of this variable is string, and then we also initialize with some value. And then what we are going to do is we can actually write here some access modifiers also. What is access modifier? The moment I say private, the variable is actually going to be accessible only inside this class. It's not going to be accessible outside this class. There is a few more things I can actually say. Static. What does static means? When I'm going to create instances of this class, fundamentals demo, this particular variable is always going to be only one. It's never going to be more than one. And all the instances of this class is actually going to share this variable. When I say final, what does it really mean? I can only assign value to this variable only in the constructor. If I write some other function, let's say let me just show you. Public void set instructor name. Let me take string instructor name. So if I say this dot instructor name is equals to instructor name, since I have written final here, it says okay, you can only assign the value in the constructor, now nowhere else. So this is not going to work. But if I remove the final, I can do it. What I'm trying to do is I'm actually saying this particular variable is private, but I can assign a value using calling a function. Why do I have this function? Because instead of anyone assigning anything, I can have checks and balances here. I can do something like this here. If this dot no, not this. If instructor name double equals to null, or instructor name double equals to this, maybe this. Yeah. So what I want to do, let me just use it. I want to throw new illegal argument exception. Argument exception. Let's see what kind of argument exception we get. Missing format, illegal, maybe illegal argument exception. We can actually use this. And we can say instructor name cannot be null or empty. This looks good. So what we have done here is we have created a variable of name instructor name, made it private so no one can access this directly, no one can change it. Then we said okay, if you want to change it, you have to call this function. We created a new function which is of type public, and then we are taking the instructor name. See the difference here, the instructor name is also the parameter name, and you also have a variable name instructor name. So to differentiate the two, you're using this. When the moment you say this dot, it actually says this one should be part of the class, not the parameter, and that's how you're using it. And you have written your own function also. What we have done is we have said if instructor name is null or empty, I'm not going to assign it to the instructor name. I'm going to throw an exception, and I'm throwing exception of a particular type. Let's go back and let's see. So this is good. We can also do something like this. So for example, this is set, and then maybe I can actually do a get also. Public string get instructor name, no variables because no parameters because I don't want to get, and I can return this dot instructor name. So here what I'm trying to do, I'm saying, okay, I'm not going to directly expose you the variable out of this class, but I'm going to give you two functions. One function through which you can see what is the current value of this variable, and the other function through using which you can set the value of this. This is also called a property. When you do it something like this this overall instructor name becomes a property of the class. Remember this property of the class, and this becomes a field of the class. Field and property. Okay. So there are a lot of good rules around how do you name the variables, how it should look like. Go ahead and read them. They'll be in your modules also. So we are not going to be spending time there. So now I said here string, but what all data types I can use? So there are a lot of data types which are like basic data types you can use. For example, you want to work with the numbers, you can use integer, long, short. If you want to work with the numbers which have precisions, like for example 1.2, you can use float, double. If you want to just use something like true, false, you can use boolean. If you want to just give me a second. Just give me a second. 2 minutes. Just give me 2 minutes. I'm actually just a moment. All right. So these are so we have different kind of data types which we can use. Some are like very basic ones, and some are the advanced ones. So advanced ones are the ones which you're going to see in your when you go back to different courses. Like for example, there are things like basic stuff like string and this. Then there are arrays. Like for example, if you want to work with multiple values, and let's say I want to have another field. Maybe this time I'm not going to make it private. I can actually make it public. Let's say I want to store all of the participant names. All of you who are participating, I'm going to store it. Do I know how many participants I'm going to get? Like for example, currently it shows us 47. When I joined the call, it was few numbers. So I don't even know how many people are going to join. So I cannot really say participant one, participant two, participant three, and so on. So I can actually go and create maybe a, string participants, something like this. So what I'm trying to do is I'm saying I'm going to be storing value participant names maybe values names, but I don't know how many I'm going to have. So and then I might have more than one value because there are going to be more participants. So I'm using something like this, which actually tells me, okay, I'm going to have an array. So you're going to learn about these things. You can learn about these things when you come to all these courses. uh, so let's actually just go back to the slide. So one thing I actually would like to hear from you is like keep actually posting questions, and you don't really have to reply me privately. You can just reply to all, and you can actually tell me which sections you already know of, which sections you want to go deeper on. So some of the things which I'm covering, I'm actually adding a lot of new insights to these concepts. So it's not like everything is not coming from the course itself. So you already know the concept of casting. I'm not really going to be spending a lot of time there. Arrays, I just quickly touch base. So you actually are doing something like this where you say, okay, I want to store participant names, and then I say new string, and then I can actually specify, say maybe 100. I say, okay, I'm going to have 100. Okay, so start with loops and functions only. Functions need functions end up. Sure, sure. So we can actually just jump there. Maybe just 3 more minutes where we actually cover some important aspects, and then we'll go to functions and loops. So we know about arrays, we know about obviously operators, we don't really have to be focusing on. Uh, if else, we just covered here, we just talked about if else, if conditions. Conditions you already know. So obviously there is something called nested if else, if you would know. Instead of actually just having if else, if you have something like this, for example, I want to actually write a code which actually is taking care of bunch of conditions where you actually say if this okay, if this okay, if this otherwise you finally do else. So there is like if nested if else which you can use. Switch case is replacement for nested if else, very easy to use. Loops. In loops, what are different kinds of loops? A while loop, for loop, do while, break, and continue. So, for example, a lot of times, so if I want to print all the participant names, uh, either are two ways. Either I can actually say participant name of 0, 1, 2, 3, 4. I can write like 100 lines, print all these characters, or I can use so looks like I'm getting constant feedback saying that directly jump into DSA. So I can actually do it, but if I just want to hear from other people also. Can you please send some DSA questions so that we can practice? No, please. So let's do one thing. Let me actually just stop here and then hear from majority of the people. What exactly do you want me to cover? Because a lot of people actually said they actually wanted to hear basics also. Uh, I want to have some depth in loops and functions. Yes, directly DSA. All right, all right. So looks like most of the people actually want the data structures and algorithms. We can actually just switch to that. That's completely fine. So let me quickly open my data structures and algorithm PPT, and then we can actually get started. Just a moment. I am actually opening my. Let me see. Just a moment. I'm opening a couple of slides which we can use to actually talk about data structures and algorithms. So linked list is one of them. Then I have, let me see, arrays and linked list, and then I also have algorithms. So I have bunch of topics, and I can also quickly have a look at. Let me just go to the functions part as well and just see if okay. So a lot of people are asking for the functions. We can actually cover functions, so that's completely fine. That's completely fine. We can actually talk about the function and then we can actually talk about the data structures and algorithms as well. All right. So what is? Let me actually just go to the functions then. We can. So what I'm doing is I'm actually skipping all the conditions, loops, and functions. I'm actually skipping all the basic data types and this. I'm directly jumping into the functions part. So what is function, right? And then maybe we can actually come back to the data structures and algorithms. So what is functions? Functions are means to operate in a particular way. So when I wrote this when I wrote this particular thing, public string get instructor name. What I am doing is I am creating a function. I am creating a function. So let's say I do this public static void main string args, and then let's say I do system out dot print line, and then I say get instructor name, Let me just copy it. And then I'm going to explain you what I'm trying to do here. All right. So maybe I can actually do something like this. Fundamentals demo. So I'm going to explain you a couple of things. I'm just writing some code for you in front of you so that you can actually get the sense. So what I am doing here, I have created a class and then I created a couple of things like fields, a couple of fields, and then I am creating a function. Function is nothing but method also. Function and methods are same. So it's actually the same set of things. What you do basically in a function is you say, first of all, what is a access modifier? Whether this function is available inside the class, outside the class. Okay, so one basic thing, which is actually public, private, you can have protected as well when you come to the concepts of inheritance and encapsulation, polymorphism. There you are also going to be reading about what are abstract classes, what are some of these protected meaning, all those things you're going to learn there. Then you actually have something called return type. Is your function returning something? Here in this particular case, I was not returning anything, so I said void. In this particular case, I said I'm returning a string value, so that's what I had string. So this is what you have. Then you actually come up with your own name, very much like the way you give a name to the variable, you give a name to your function. And then the last thing which you do is uh, you actually say what are the different parameters you're going to accept as part of your function. So you can actually not have any parameters, or you can have more than one parameter. And then and then this is what internally it's just a code which you write. I'm writing a simple line of code, multiple lines of code, you just write that, and you call the function. When you're calling the function, you say you create an instance of the class. You create the instance of the class, and then you say dot and you call the function. The only difference with this and the other one is, so for example, I could have something like this. uh Public static void print greetings, and I can say system dot out dot print line welcome to upgrade. So for example, this is what I want to write. So here, if I create a static function, uh, if you create a static function, what you can do is you don't really have to create an instance of the class. You don't have to create an instance of the class. You can actually directly just say print greetings. You can directly call the function without actually having the instance of the class. Okay, so that is the key difference between a static function and non-static function. Let me just see if the from a from a function perspective there is anything I need to cover. Otherwise, we can actually jump into data structures and algorithms. Functions. For parameters we covered, then pass by value, inbuilt functions, and reading from a file, exceptions, writing to a file. Okay, so I think there is one more thing which we have to actually cover, and then we are good. So when I say system dot out, the out is nothing but actually a class. If I go to the definition of this out, let's say go to definition. Just give me a second. Let me actually just change the setting of this. IDE Visual Studio. Okay. So if I go to the definition of out, if you see, it's actually part of system namespace. There is a class called system, and out is nothing but an instance of print stream. If I go to print stream class, there is going to be print control F print line. Okay, so let's say where this println is. Let me just go down. Okay, so here we go. Here is uh, the function print line. So if you see, when I am actually writing this code, I said system dot out dot print line. When I call this function, this is a inbuilt function. This is a function which I am calling directly. I am not writing that function here. I'm just calling a function. I'm just calling a function and then passing it something. What am I passing? I'm not passing anything here. I'm calling inside this function. I'm calling another function. I said demo that get instruction name. So how the things are actually going to work? First, when the compiler comes to this line and when the okay, so what I have actually done here, you just hear me out. This is important. When the runtime engine comes across this line, Java runtime engine, it knows that I cannot directly call this function. So first it is going to call this function get instructor name on the demo instance. Once the demo instance this particular gets called, it returns instructor name. It has a string value. Then the print line function is going to be called with the value which we got from this instructor name. Okay, so let me see if I have some question because then we are going to move to the data structures and algorithms. Uh, let's start from here. So, what is the difference between an interface and an abstract class? I get a lot of confusion while working with these two. So, this one I have written a fundamentals demo. So, if let's say I say, I have bunch of examples directly. I don't really want to code that. Let me actually just go quickly there, and I can show you here. So if I want to, I don't really want to say how the implementation looks like, but I want to say there should be a class which should have this implementation. What we do is we write interfaces. Let's say, for example, I want to have a count class. There should be three functions which I want to expose. Get balance amount where I have a Boolean variable and print account type. So this is what is interface. Now, if let's say I come up with an implementation for this I account, but I say, okay, no one should create an instance of this class. No one can create the instance of the class. So so what you are actually going to do is you can actually say abstract. You can have bunch of implementation, but you say you are going to have further classes. Let's say here in this particular case I have a savings account which is extending from account where I can create an instance of this class. So abstract, inheritance, you're going to come across all these topics when you actually learn about polymorphism and the other OOP concepts. So I think otherwise it is just going to be confusing for most of the people. The next question was input stream and output stream. You can actually skip this part. It is all implementation Java. It is as far as you can use the system.out, that's fine. System.out, that's actually good for you. Instance, nothing but a copy of the exist. Okay, someone was replying. Good. Okay. So can you share the PPT? There is no PPT we are using today because we are using multiple PPTs, so we are not actually using any one of PPT. Abstract class. Okay, someone was replying here. So now I'm going to stop actually the functions part, and then now I want to hear from you. When you say DSA, what are the data structures and algorithms you are interested to know? Because there are hundreds of them, and then we cannot cover all of them. So I want to know from you which DSA, when you really say DSA, what is it you are looking up to? And then I'm going to be switching to the DSA part. I have all the data structures and algorithms which we can cover, but I just want to hear from you which one you want to hear. Graphs and linked list, time complexity, basic DSA, string, recursion topic, recursive functions. Okay, a lot of people are asking for recursion. We can talk about recursion and then we can actually, okay, so just stop. I can actually talk about the recursion part and then we can actually just jump into some of the algorithms part also. So let's say this. Let's take a quick recursion example. let's take a quick recursion example. Let me actually just think about some good example where I can explain you. I can actually just write random code also. Uh, but maybe taking some good example of recursion, I can explain you what recursion is. Okay, take a very simple example. Let's say let's say we actually want to just add numbers from 1 2 3 4 5. So I give you a number n, and then I want you to add till number n. So n could be 100. So when I say 100, add 1 2 3 4 5 6 all the way to 100. If I say 200, I add all 1 2 3 4 5 6 7 8 all the way to 200, right? Very simple basic things. So here I can actually do two things. So I can actually just quickly show you that example. So let's say we write public static void sum of n sum of numbers. This and then I take integer and I take a number n. So there are two possibilities we have when we write this code. One possibility is I can actually say for int I is equals to 0, I is less than not really, I is equals to 1, because I have to start with 1 here. I is less than equals to n, and then I say I plus plus, and then I can actually maybe I can declare a variable integer sum is equals to 0, and I can say sum plus equals to I. So basically, this is what I'm doing. If I want to add a bunch of numbers, if I want to add a bunch of numbers, I can actually just go through one to till that number and just add all of them, and that is how I can actually get some number. And maybe here I can just go and print like this: system dot out dot print line the sum for numbers, the sum for maybe I can actually say n numbers. Okay, so let's also call this function from here. So we can actually see, and then I'll take this, I'll write the same code as recursion. So let's do here. Let me just call sum of numbers and say I want to say 110. Let's just run this code and then let's see what happens here. Okay, so I called this print greetings. It actually said welcome to upgrade. Then I said print line. Then inside that I was doing a function call, so it was actually get returning me the value which was coming to it. And then finally, it says the sum for the number one for 110 numbers is 6105. So, but the same function now we can actually write using recursion. So, what are we going to do in the recursion? We will say sum of numbers recursive integer n if n double equals to 0, return 0. Otherwise, what we are going to return is return sum of numbers recursive, which is going to be n minus 1 plus n not going to be here. I'll say integer, and then here let me actually just say Uh, let me just copy this. For number say 110 is some recursive 110 something like this. I'll explain. I've written some code and then we'll actually are we are actually going to change this code also if things are not going to work. And then let's say what happens here. We just run it. Okay, so things actually it was a right code. So what we do in recursion is we call self. In the recursive functions, we call the function itself. So when I said sum of numbers recursive, the sum of numbers recursive is trying to call itself. And then obviously, when you're calling yourself, you have to really figure out why am I calling myself. So in the case of this numbers 1 plus 2 plus 3 plus 4, you know that when I'm actually trying to find out the sum for 3 is nothing but sum for 2 plus my number itself. Sum for 110 is nothing but 110 plus sum of 109, right? And then similarly, and sum of 109 is nothing but sum 109 plus sum of 108. That's very recursive function. So whenever you come across this kind of problems where you actually can realize, okay, it's nothing but a recursive function, you can use recursive function. The key for recursive function is your exit condition. You should have an exit condition. If you don't have an exit condition, you are always going to be in a loop. Your memory is actually going to get bloated up, and then the function is actually going to crash. So having a right exit condition is actually important. Sometimes things can be done using for loops. If it can be done using for loops, why not do it? Because it's actually going to save you a lot of recursive calls and function calls. But uh, uh, if uh, if you actually you realize, okay, this is something which cannot be really done using the for loop, and I should really do it using recursive call, because it actually makes things much easier. You can actually go use the recursive functions. uh, So let's see if I have questions. So algorithm, okay, so recursion was the one. Are all recursive functions exponential? Why do we still choose recursion? So like I said, you can use recursion. You can use recursion for some cases where it can actually help you solve a problem faster, and then much easier to write code than actually trying to figure out how you can use for loop and while loop. But a lot of functions without recursion you can actually solve. So you don't really recursion is just one way of solving a problem. It's a good concept. People love it, and so let's move on. Now let's actually go to the other part. So algorithms, maybe we'll actually start with the, let's see. Maybe I can actually talk about the linked list, and we can actually take some questions also for the linked list. We can actually go like that. So uh, let's start with basic thing like what we did here. When I was actually storing the name of parties myself, I was able to just create a simple variable and create of type string, and then just assign the value Imran to it. Very easy, right? But when I wanted to store all of your names, actually it's not going to be as easy. I cannot say participant 1, participant 2, participant 3, and so on for all the 48 participants. I have to have some easy way to do it. So I can use array participant names, and then I can say, okay, I don't know how many participants are going to be here, but right now I know it's actually 48. I can actually say 48 explicitly. But when you start write this code for each of the session, you don't know. So maybe I'll come up with some number, say 100 or something. So this is one way of actually doing things. But the other way is you can actually say, if you don't know the number of participants upfront and you don't really want to just waste your memory space also. For example, if let's say there is machine learning sessions which I do, I get only like 8 to 10 participants. So there all the 80 to 90 variable instances in an array are going to be wasted, because there is not going to be those so many participant names which I want to write. In your case, sometimes I get actually all the 100 people also, and sometimes more than 100. So in case of more than 100, how am I going to store the extra names? Okay, so the array has some limitation, and that is where the array list comes into picture. So if you see array list, what we do is we dynamically we say, okay, we don't even know how many people how many people are going to be joining the session. So let me just say, okay, I create a student list. This is what the data structure looks like. I use a array list, and then I say student, and then depending on who is adding, I can just keep adding the names. I can keep adding the names. I can keep adding the names. And then obviously one thing you see here, I'm not actually, this is interesting. So I said array list of student. Student is not one of the data types which you would have actually seen so far. So student is my own data type which I have created. So when I go to the definition of the student, it's my own class where I say I'm going to store two now, two information, name and roll number. And in my array list, I'm creating an array list of type student, and then I can on the fly add this. So if I get 8 students, I'm going to create eight. I'll occupy 8 space in the memory. If I get 100, I'm going to use 100. So the other one, which is actually in line with the array list concept, is called linked list. So what happens in the linked list? You actually uh, it's very much independent of so for example, if you have a lot of participants which you want to store, in case of array list, all of these are going to be stored together in the memory. And if you say no, 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 I don't want all of these things to be together because I don't even know in how my memory structure looks like in my computer, can you actually assign them anywhere in the world and thus maybe just join them because be it together. So that is where the linked list comes into picture. In case of linked list, what happens? We Let me just see. Let me just keep the chat session open. Yeah, if any question is coming, I can actually see it. Uh, there is a mid poll session also. I need to start. You can quickly reply to this mid poll session also. Just take 30 seconds and reply to this mid poll session. I'll continue talking in the meanwhile. Linked list, very, very higher level. The way we actually work with a linked list is we actually say, let me also see if I have some picture to show you for the linked list. Yeah, because that will actually also explain you. Uh, yeah, maybe actually this particular slide is good enough for the linked list. So what linked list is? A linked list is a series of connected nodes. You say, okay, each of these student names are independent. They can be anywhere in the memory, but I want them to be connected. So I can actually say, okay, first participant name who actually joined in. Let me actually just look from here. So let's say the first participant name is Abhijit. So Abhijit, I create a new variable, assign a value Abhijit to it. Then I add another node, you call it node in case of linked list, and I add a new name, say Ankit Kumar, and then I just join them. So these two names in my memory can exist anywhere, but they are all joined together. So I can start from Abhijit and I can keep on going for all the student names until I reach Smriti, and then I stop there. And then the last node you're going to have is actually going to point to null. It is going to say I'm the last node, so there is no one who is coming after me. So, what is a major what is a major advantage of linked list? You in case of linked list, you are saying obviously I don't know when I start right storing the names of the storing the names of the variable. Sorry, the storing. Let's say in our case is student names, right? So when we start, I don't even know how many students are going to join the session. So obviously I cannot use arrays because arrays is just going to waste my memory, or in some cases I'm going to run out of number of names I can store. Array list, I very well nice, I can do it, but array list actually says I'm going to be storing everything sequentially. What if I have 1000 students and there is it keeps on reallocating my memory every time actually it runs out of space for the new names. It goes and moves everything to a different place. So obviously I cannot use array list. Maybe linked list is a good option. I actually go keep on creating names, and wherever it finds space, my runtime is actually going to store those names and link them. And then it is super powerful. Just think about different search algorithms which you can do. So you want a data, let's just think about the memory problems, right? Sometimes you don't really have all the memory available in your computer. Whatever you have, can you use can you make the best use, optimal use of those memory? and still get your job done, and that is where the linked list comes into picture. So what you do is again a data structure. Let me just go to that example. It's again a data structure which is actually available in the as part of Java implementation. You can write your own implementation of as well about the linked list. You can write your own implementation also. Sometimes when you go back, just go and read more about link, how you can actually go, you have your own implementation of linked list, because in the interviews you might be asked to write the implementation of linked list. You might be asked. So in Java, I can just say linked list and I have the implementation available. I don't really have to write my own code. But when you go for the interviews, they will be asked to write the implementation of linked list and also solve some problems. So here in this particular case, it's very easy. What I'm doing is I say, okay, linked list, student list, and I keep on adding I create a bunch of students, I add them to the list, and I can go remove it, I can go print it, I can do everything in the linked list, right? Just simple stuff. So so let's actually just focus on this linked list maybe, and then focus on what kind of questions that can be asked in your interviews. Uh, so some basic question. What is linked list? What is linked list? What is the type of memory allocation? Okay, so there is another thing called traversal. Anyone of you know what is traversal? Can you talk? Can you actually explain maybe in the chat window what is traversal? Visiting each node. Yeah. So in case of linked list, when I say uh, print student list, I'm actually going through each node. Maybe I can actually quickly, since we have time, I can create a linked list for you and show you. So new Java class linked list demo. Maybe this is our class. What we do is, in the linked list demo, maybe I can have another class here, new Java class called node. So node, let's say I am creating a linked list node. I'm creating a linked list node. What do I want to store? I want to, let's say, store the name of the participant. So I'll say string uh, participant participant name. That's all I'm going to store. But if you remember in linked list, what we do, we actually also store pointer to the next node. So I'm going to say node next. These are the two things I'm going to have. Just simple, plain, basic stuff. If I go here in the linked list demo, I can I can go and create first node. I can go create a first node, and then first node we call it root. Okay, so we'll create a new node, and maybe we can assign some value root dot. Let's say if we can just make it public, we can make it public. All right. So root. Oh, sorry. I have to do this. Public static void main string args, and then I'll say node root is equals to new node, and then maybe I'll assign the value root dot participant name is equals to let's say some name John. Since I haven't done anything, the way things are actually going to work is I have created the first node. Since I don't have any more nodes, the root dot next is actually going to be null. Root dot next is actually going to be null. Then I can maybe create say a couple of more nodes. So I can actually say root dot next is equals to new node, and then maybe I can say root dot next dot participant name is equals to JSON. All right, and I can continue doing it. So this is what I am actually creating. So what I then I can do is I'm always going to have access to the root node. I don't really need access to any of the other nodes. Remember, I'm not actually explicitly creating any parameters here. I'm directly just using this pointers to actually create the new instances. I can actually maybe create one more just to show you as an example, and I can just say maybe here Nick. So now if I want to traverse this particular linked list, what I can actually do is I can say while, maybe I can actually do something like this. Node, uh, traverse, current node. I can actually do something like this. Current node is equals to root. While current node is not equals to null, I am actually going to say I do this sys, system dot out dot print line. I say current node dot participant name, and then I say current node is equals to current node dot next. So basically I'm actually just traversing it, and then since I have access to the first node, how many number of nodes doesn't matter, I can just traverse it. Let's just run this code. So what we are going to do is we are actually just going to do you see a problem here? Do you see a problem in the code? Can you find out the problem in the code? Can someone find the problem in the code? There is a problem in the code. Anyone can find out the problem in the code? There is one problem in the code. JSON node not printed. But why? Why the JSON is not printed? Yes, for the last node it is null. It is not picked up in the condition. Both are next dot participant. Yes, you are right. So the answer from Ujjwal is right. So if you see here, this is the mistake. I said root dot next is equals to new node. And then I said root dot next is equals to new node again. So what I have to do is I have to say root dot next dot next. Now let's see what happens. Let me just run this code again. Now everything is printed, right? Uh, John, Jason, and Nick. Everything is printed. Just give me a second. I'm coming. Just give me a second. All right. So let me just go back to the PPT again and let's see. Uh, Okay, so the other kind of questions, these are like very simple kind of questions which you can come across in interviews when you go. They might ask you what is linked list, what type of memory allocation that happens. Traversal we already discussed. What are nodes? What are really nodes? And can you just write down the code? And what are the types of linked lists? So one thing which we have actually studied so far is we have actually talked about uh, only one type of linked list, which is called singly linked list. Here, what we are doing is we have just singly linked list. What happens in the what there are other kind of linked list also. There is something called double linked list. In case of double linked list, I have a next pointer. So for example, if I'm the current node, I know what is the next node. I also have something called previous pointer. So I can also point to the element before me. So in case of normal single linked list, I know only the element after me. In case of double linked list, I'm going to know the element before me as well. That is important. Uh, then there is something called circular linked list. What happens in the circular linked list? Circular linked list, the last node points to the first node. Last node points to the first node. So if you see, if you can just visualize in your brain, it is actually going to form a circle because first node points to second node points to third node, and let's say third node is the first node, sorry, last node. The third node is going to point to the first node. So you are going to form a circle. In circular linked list also, you could have single circular linked list and double circular linked list. So there are a lot of those kind of linked list which you should know of. Let's see. So another kind of questions which you could actually been asked are what is the difference between array and linked list, which we already covered. Single linked list, application of linked list. What are the application of linked list? And this is important because, for example, when I say linked list, you should actually know the applications of linked list also, where the linked list are used. What is a where I cannot use array list, where I cannot use arrays, where really linked list is only option. Those things you should know. Difference between singly and doubly linked list we already discussed, and then operations allowed in linked list. What are the operations you can perform? You can traverse, you can add, you can delete, you can do a bunch of things, right? Those are the operations. So let's actually talk about some questions, and maybe we can actually take this as an example and go over it and also talk. So one thing is rotate a linked list. This is a very classic. That is a very classic example which you're going to interview question which you're going to come across. Lot of time this question gets asked. How do you rotate a linked list? Let's say you want to rotate a linked list. Okay. So let me just close this particular part. So I have already questions actually. I have actually taken this session some time back where I was talking about this. So obviously, if you see here, uh, we every time you are going to be coming across these kind of functions, uh, every time you are going to be coming across interview question related to linked list, first thing you're going to do is you're going to write your own linked list node. Here, very similar to our one, we actually have integer here integer value. In our case, we were actually storing a string, which is okay. You can actually store anything in your nodes. Then you have a next pointer. So this is what the class implementation is. Now, what is the problem statement? The problem is given a single linked list, rotate the linked list counterclockwise by k nodes. You want to rotate the linked list counterclockwise. What is counterclockwise? If you go from in your clock, if you go 1, 2, 3, 4, 5, that's actually clockwise. And if you go 12, 11, 10, the other way, it's actually called counterclockwise. So where k is a given positive number. So you have a big linked list, you get some number k, and you want to rotate that linked list by k nodes. So for example, there is a good example given also. If linked list is like this 10, 20, 30, 40, 50, 60, and k is 4, then what you want to do is you want to rotate it something like this. Your 10, 20, 30, 40, these four numbers should get pushed after 50, 60. So 50, 60, and then 10, 20, 30, 40. So it is like just think of this as a circular linked list where 60 points to 10, 60 points to 10, and then you said okay, my root node was currently pointing to 10, but my root node should actually move by 4 positions. So 1, 2, 3, 4. So now I'm pointing to 50. So 50 was anyways pointing to 10. So you actually have a very nice way of rotating the linked list. So let's take an example also, like how we can implement this kind of code. Uh, let's start with the basics. So obviously the basics here, you create a class, you create a node, and then you say okay, how my node is actually going to look like. Then what you do is you do this. You actually have some basic functions also in the linked list. How you're going to print linked list, how you're going to push the new node in the linked list, some basic functions, right? And then you're going to have a driver function as well. In case of driver function, what you do is you create a linked list, you initialize with some values, then you actually print the linked list, you rotate it by k number, and then you are actually going to print the linked list again, some driver function. But the real function, which is actually the rotation, is this one. So we are actually going to see this one, this particular code. So what happens in this particular code, in the rotation code, what we are actually saying is we are saying, okay, if the number of nodes is 0, then we don't have to do anything. Everything is great. No, nothing needs to be done. Otherwise, we actually do this. We initialize a new variable current and we point it to the root node. What is root node currently? It's 10. So I am actually pointing to 10. Then we are actually saying current will either point to the kth or null after this loop. Current will point to 14, the example. So we traverse the root node number of how many number of times? K number of times. If k is more than the total number of linked lists, anyways we are going to stop. We have this condition. If current is not equal to none, then only we are moving, otherwise not. So we start with count 1. We go till count is less than k, which is 4, and then we say if count is less than 4 or the current node becomes null, either of this condition gets satisfied, keep on moving, moving. We actually say okay, now we started here, count was 1, we went to 20, count was 2, we went to 30, count was 3, we went to 40, count was 4, stop. So now we are 40. Now we are checking again if the current becomes null. If actually I reach a state where the number of nodes in the linked list was lesser than the number you provided. So there is no rotation I can really do. I'm going to stop. So I'm just going to return. Otherwise, what I'm going to do is I'm going to say the kth node is this one, whatever my current position. So if I had, say here I had 6 nodes and then I give you a number 4. So I can easily go to the fourth number, right? Then I can say what is my a node at the fourth location? I'm actually pointing it here. So far so good. So now what we do is now I want current will point to the last node after this load on a loop. Current will point to the next node 16, the above example. So for example, if you see, I am doing while current dot next is not equals to null, current is equals to current dot next. I say okay, now go till the end, go till the end, and uh, if you remember this, current dot next is equals to head. Uh, if I keep on traversing the linked list and if I go to the last node which is 60 here, which is 60 here, the 60 is going to be pointing to null, right? It is 60 is not going to be pointing to anything. So what we do is we first traverse a linked list, go to the kth number of the linked list. We say, okay, I just get hold of this one, then go to the end. It says go to the end. In our case, 60 is then. I go here, then I say instead of you pointing to null, can you point to 10? So it will point to 10 now. Then I actually say, okay, 40, you were pointing to 50, don't point to 50. Just stop pointing to 50, and that is the next change which you would see here. So here I said current dot next is equal to head, head is equal to kth dot next, and then I said kth node dot next is equal to null. So this is the way I have rotated my linked list by kth position, by kth position. So what and then this can be generalized. Maybe I can actually just run this code and show you. Let's say we have uh, we do this 120. Let's say we do uh, let me just write here till 120, and then let me just give you a number, say 8, and let's see what happens in the linked list. So let me just run this code and show you. So initially I had 10, 20, 30, 40, 50, 60, 70, all the way to 120. Then I said, okay, rotate at the 8th position. So when I go as per my code, I'll go keep traversing. I'll stop here and then I'll say, okay, this just hold it. And then I'll go again till 120. I'll say 120, please point to 10. So 120 is pointing to 10. And then I'll say the 80th location should point to null. 80th position is going to null. So my linked list is going to start from 90, 90, 100, 110, 120, 120 points to 10, and so on until I come to 80. 80 is the last one. So that is how I have rotated it. This is just one example. In your interviews, you are going to come across lot of similar questions. Like for example, how do you delete the middle of the linked list? How do you detect a loop in linked list? How do you find the nth node from end of linked list? A lot of questions. A lot of all of these questions actually have different answers. So we cannot really go and solve all these answers. But one thing which some of you have asked is talking about time complexity and space complexity. Let's go again. So when someone asks you time complexity and space complexity, you're not going to be actually doing it for the node declaration. You're not going to be doing for the helper functions. You're not going to be doing for the driver function. You're just going to be doing it for the main function, which is actually the main code. So the main code in our case is this rotate code. So how do we actually calculate the time complexity? If you see here, time complexity has some rules. It says simple statement time complexity is 1. So in this particular case, the time complexity is 1. Again, simple statement, the time complexity is 1. Here, time complexity is 1. Now for all the loops, they say time complexity is going to be n. So, so there is a while loop. So the time complexity is O of n. Here again, simple statement. If conditions, so the conditions, if else, all these things are simple statements. So it is O of 1. O of 1, O of 1, O of 1, O of n, O of 1, again O of 1. Again, I have a while loop. So I'm going to have okay. So I have a while loop, so it is going to be O of n. Then again, I have a simple statement, it's going to be O of 1, O of 1, O of 1. So the rule of time complexity calculation is you add everything. So O of 1 and O of n, keep on adding them. And whatever is the largest one out of all these is actually going to be your time complexity. So in this particular case, the largest one was O of n. So my time complexity is here is going to be O of n. Now, space complexity. How many extra variables you are going to create? I'm not creating any variable here. I'm creating one here. So it's going to be s of 1. I'm creating another one here. So s of 1. I'm not creating anything here. I'm creating one more here. So s of 1. I'm not creating anything else anywhere. So I have created three times one variable. So we just calculated as one time. So my space complexity is here is s of 1. My time complexity is O of n. So that's the whole idea of calculating that space and time complexity. So now we are running out of time also. So I can actually take maybe one or two more questions. Can you just now write down the questions in the chat window, and I'll quickly go over all of this question. I'll keep answering. So can anyone please confirm if you covered arrays and string manipulation, coding questions and concept before moving to linked list? So I think this is for the people. So can you guys now write down the questions for me quickly? I'm going to stop sharing my screen also, and I can just go over these questions fast, and then we'll end the session as well. So let's quickly go over the questions. All right. So all right. So let me actually just go through the questions again. So one question was, Imran, can you please repeat time complexity and space complexity? It is a bit confusing. It is very complex topic. And I have actually taken one complete 2 hour session on just time complexity and space complexity. So we actually, so here what I have actually tried to do is just give you a summary about how things actually calculates. What is time complexity? It tells you how your code is, how complex your code is. If you're and then in the interview questions, what they try to do is they ask you to write. If you forget about space complexity for some time, just focusing on the time complexity. The time complexity is the key which is going to tell you how good your code is. So Google search, the main focus for them is really reducing the time. When you search something and you get the instant result, what is it you are looking after? The time performance, right? And that is the key here. That is the key here. Uh, so time complexity calculation actually has a lot of rules and ways and steps in which you do it. So you are actually going to come across all these concepts in your sessions later. So this is just think about this as the precursor to your session. Time complexity of recursive functions. What is going to be the time complexity of recursive functions? Because they are calling themselves. They are going to be calling themselves. So if it can be exponential, it can be linear depending on what is the condition in which what is the input arguments you're passing to the recursive function and what is your exit condition. That is going to decide how the time complexity of your recursive functions are going to be. In the rotate code, we made the linked list a circular list and broke it again, right? Yes, the reason for doing that was we don't really want a circular linked list. We just did it in order to solve the problem. Code to generate this pattern using recursion. Yes, you can do it. You can actually use a lot of, you can write a lot of code using all the functions. Any other question before we actually end this session? Just leverage this time to ask any clarification question. Any other questions coming from your side, which actually uh, talks about, okay, are there any standard techniques to address algorithmic problem? Uh, so the best thing you guys can do is once you start learning about data structures and algorithms is there are a lot of good websites like Geeks for Geeks is just one example. There are a lot of other websites also which you can go and just have a look at the code they have written and then solve different interview questions. I think that's going to give a very good sense. Any basic Java to cover most before DSA? You don't have to, since like you guys know data types. You are able to use data types and conditions and loops and everything, you are good. You can just jump into DSAs. Last question. Are Can you tell some interview question? All the interview questions which I covered here about the linked list were just examples. Interview questions are going to be really broad. For each of the data structures you're going to learn, binary trees, binary search trees, machine learning algorithms, everything. The interview questions are going to be really different for each of these. Uh, let's see. Uh, what else? Not able to submit the end poll session. Yeah, I'll just end the end poll session right now. Close it. And looks like we don't have any more questions. So I'll give you back 10 minutes. Thanks a lot for today's session. Talk to you again. Bye bye. I can actually do one thing. Just a moment, everyone. Let me actually give you my LinkedIn ID also. If you have any further question, you can reach out to me and ask me those questions there. I've actually, sorry, let me just ping it to everyone. I have posted my LinkedIn ID. You can actually reach out to me if you have any further questions. Thank you so much for your time today. Have a great day. Take care. Bye bye.